Alright, in this video here we're going to be talking about how to simplify trigonometric expressions. Alright, so if you haven't seen the video that I did on trig identities, you should check that one out because I kind of go through like an overview of all the different trigonometric identities that we can use to simplify trig expressions. Alright, so when we're simplifying expressions in algebra, like forget about all the trigonometry for a second, but if we just have this algebraic expression that we need to simplify, well, some of the techniques we use are factoring. Right, we can factor things to try to break them down. If we have fractions, we use common denominators to combine things together to try to simplify them. We can use special product formulas if we have something raised to a power. We might square them and multiply them together. So when we're simplifying trigonometric expressions, we use those same algebraic techniques, but we also pull in some of those fundamental trigonometric identities that I just mentioned on that other video that I just did. So we use some of those trig identities to also allow us to simplify the complicated expressions that we have and try to write them as something simpler. Right? So when we're doing these types of problems of simplifying trig identities, we're using the trigonometry stuff, but we're also going back to the algebraic skills that we should have by now, the factoring, the common denominators for fractions, the special product formulas, any other type of algebraic tools that we have, we can use when we're working with these trigonometric expressions. Alright, so that's just a brief introduction to this. I'm going to pause the recording here and erase this stuff, and then put up the first example, and we'll go through probably 2 examples in this video where we simplify some trig expressions and see how we use these techniques. Alright, first example we got here, cosine t plus tangent t times sine of t. And I want to simplify that. I want to try to write that as simply as possible. Alright, so the first technique that we usually use when we are trying to simplify trigonometric expressions is to express everything in terms of sine and cosine. Right, so my first term here is cosine of t, so that's already a cosine, so I don't have to do anything with that. Right, so cosine t plus, now tangent of t, there is one of those fundamental trig identities where I can write tangent t in terms of sine and cosine. Right, tangent is equal to sine over cosine. So tangent of t I can write as sine t over cosine t, and then times this other sine t that I have over here. Right, so that's one of our major techniques that we use when we're simplifying trig expressions. If you're looking at this and you're not sure where to start, write everything in terms of sine and cosine. And then when everything's in terms of sine and cosine, we can maybe combine them together and work with them that way. Right, so if I have this now, well, I have this fraction over here, sine t over cosine of t multiplied by a sine of t. Right, if it helps, think of that as sine of t over 1, and then when I'm multiplying fractions, I multiply straight across. All right, so this is going to give me cosine t plus, and then sine t times sine t is going to be sine squared of t, and then cosine t times 1 is going to be cosine of t. All right, so I end up with cosine t plus sine squared of t over cosine t. All right, so I'm making a little bit of progress here. It's still not really that simple. It's a little bit better. Instead of having 2 things here multiplied together, I have one single fraction, but now it's a fraction, so that's not really that great. So what else could I do? Well, since I have something added to a fraction, well, I can add fractions together. That's an algebraic thing that I know how to work with. Again, think of this cosine t over here as being cosine t over 1. Right? I have to find a common denominator with the 2 fractions. Well, if this is a cosine t and this is a 1, the common denominator is going to be cosine of t. Right? Which means I need to take this fraction on the left, cosine t over 1, and multiply it by cosine of t over cosine of t. All right, if you watch the other videos that I did, previously on algebra and rational expressions and how to add and subtract rational expressions, we're doing the same thing here, right? When I'm adding fractions, the rules for adding fractions say if you want to add 2 fractions, they have to have a common denominator. Doesn't matter whether that denominator is a number or just an x or an expression that involves an x or an expression that involves trigonometric functions. That doesn't matter. The rule for adding fractions is find a common denominator for your fractions. All right, so if this one's a cosine of t and this one is a 1, just like what I do when I'm adding 1/2 plus 1/3, I multiply the top and bottom by the same quantity. Right here, to make this denominator 1 into a denominator of cosine t to match the other fraction, I have to multiply the top and bottom by cosine of t. Right? Same rules for dealing with fractions. Don't get flustered just because, well, my fractions have trigonometry in it now, so this is like all different. It's not different. Right? If you're finding a common denominator, you do that. Right? So that's what we do. So now in my numerator, when I do cosine times cosine, that's going to be cosine squared. Right? So I get cosine squared of t over cosine of t plus sine squared of t over cosine of t, right? And now, from what I had up here, right, I now have two fractions that have the same denominator. Now I can add together those fractions. All right, so I'm making some kind of progress here. Let me bring this up. So this is going to equal, if I put this in one single fraction, right, cosine squared of t plus sine squared of t, all of that over cosine of t. All right, and now before I go on to the next step, a lot of people, when they're doing these types of problems, the common complaint or the common problem that people have is, well, where do I stop? Like, how do I know that I've simplified this enough, right? And the answer to that is, if you can do anything else with the expression you have, do it and keep working on it until there's really nothing else you can do, right? So, I had the tangent here. Well, I can change tangent into sine over cosine, so let me do that. Right? I can multiply this times this. All right, so let me do that. Well, I have something added to a fraction, so I can find a common denominator and add those two fractions together, so let me do that. As long as there's still something else you can do, you have to do it and see where that leads you. Right? So now we have this, cosine squared of t plus sine squared of t over cosine of t. Is there anything else we can do there? There is. Right? This comes back to another one of our fundamental trig identities. The one, I'll put it down here. All right, sine squared x plus cosine squared x equals 1. Right? That's one of those Pythagorean trig identities, the most important one that we need to know. This comes up a lot when we're doing these types of problems, so it's a really important identity to know. Right? And that's what we have here. Like, we have t's instead of x's, but the variable we use doesn't matter. Right? If I have a sine squared plus a cosine squared, it's going to equal 1. Well, what I have here is cosine squared t plus sine squared t. Does it matter that the order is switched around? Since it's addition, the order doesn't matter. Right? 5 plus 2 and 2 plus 5, they both equal 7. I can switch the order of addition. Same thing here. Right? So cosine squared of t plus sine squared of t, that's going to equal 1. Right? So I can do that. I can use that identity to write cosine squared t plus sine squared t as 1. And now I get something really simple, 1 over cosine of t. Right? Compared to what we started with, this is a whole lot simpler. Now, is there anything else I can do with that? I can. Right? Because this is one of my reciprocal identities. Right? Remember, cosine is the reciprocal of the secant function. So 1 over cosine of t, that's equal to secant of t. And once I get it down to a single trig function, just secant of t, there is nothing else I can do with that now to try to simplify it. If you're starting with a problem like this and you get it down to where it's just one single trig function all by itself, that's as simple as it could possibly get. Right? So that's our simplified version of cosine of t plus tangent t times sine of t. Right? And if you want to check it out, like if you're doing one of these problems and you're not sure you did it correctly, you can just plug a number in. Do like, if your calculator's in degree mode, do like cosine of 30 plus tangent 30 times sine of 30. See what that answer is, and then do secant of 30. So do like 1 over cosine of 30. It should give you the exact same answer, no matter what number you decide to plug in for t. All right, so that's a way you can double check to make sure that it came out correctly. And if they come out to two different numbers, that means you made a mistake somewhere. All right, so that's our first example of simplifying a trig expression. Again, turning things to sine and cosine, combining fractions by finding a common denominator, looking out for when we can use this Pythagorean identity, when we have the cosine squared plus sine squared, using those reciprocal identities. All those things come into play when we're doing these types of problems. All right, I'm going to pause the recording and erase this one and then put up another example that we'll take a look at. All right, so for this one here, we've got sine theta over cosine theta plus cosine theta over 1 plus sine of theta. And we're asked to simplify this expression. So the first thing you might see, you say, well, sine over cosine, we saw that in the last problem, that's tangent of theta. So let me change that into tangent theta. That's actually not going to help us here. Normally what we want to do is express things in terms of sine and cosine. So if I had a tangent here, I would actually want to write it as sine theta over cosine theta. What I want to do is create fractions, because if I create fractions, that allows me to find common denominators and add fractions together. And when I do that, as we saw in that last example that was just up here, when we add those fractions together, a lot of times that leads us to something that simplifies or cancels out. So we want to create those fractions if we don't have them, and then combine them together. So I don't want to take this fraction and turn it into just tangent of theta, because then I won't be able to do anything to combine it with this other fraction over here. Right? I want to leave it as a fraction and just find a common denominator for my two fractions. Right? And then add those fractions together. So anytime you're doing one of these problems, if you have fractions, generally what you want to do is do the common denominators to add them or subtract them depending on what you've got. All right, so this denominator is cosine of theta. This one is 1 plus sine of theta. And so my common denominator is going to be those two things multiplied together. Right, which means this first fraction over here, I'm going to have to multiply the top and the bottom by this denominator. Right, so it's going to be sine theta times 1 plus sine of theta over cosine of theta. Let me just put all these in parentheses. Cosine theta times 1 plus sine of theta. Right, so for this first fraction, I multiply the numerator and denominator by that other denominator. And then for the second fraction, I'm going to do the same thing. Right, I'm going to have, now both my top and bottom are going to get multiplied by the denominator of this fraction, which is that cosine theta. So it's going to be cosine theta times cosine theta over the original denominator here, 1 plus sine theta, times the other denominator, cosine theta. Right, so I took what I had here and multiplied both the top and bottom by this denominator, cosine theta over cosine theta. Remember, I can multiply the top and the bottom of the fraction by the same thing, because that amounts to multiplying it by 1. Right, cosine theta over cosine theta equals 1, so I'm not changing the value of my fraction, and that's the strategy we use when we're dealing with fractions or rational expressions in order to find common denominators. All right, now my two expressions have the same denominator, which means I can add them together by adding together the numerators and keeping that denominator the same. All right, and what I do, I'm going to kind of do two steps at once here. I'm going to multiply this out, so I'm going to distribute this sine theta into that, parentheses there. So sine theta times 1 is going to be sine theta plus sine theta times sine theta is going to be sine squared of theta. And then I'm going to add to that, when I multiply these two together, that's going to be cosine squared of theta over my common denominator, which is cosine theta times 1 plus sine of theta. All right, so I've got that. I've got my common denominator. I multiplied out my numerators. I added the numerators together. And now, what else can I do? Well, take a look at this. Once again, and I said a few minutes ago, this comes up all the time. Part of my numerator, not my entire numerator, but part of it is sine squared theta plus cosine squared of theta. That's our Pythagorean identity, sine squared plus cosine squared equals 1. Right, so anytime you see that pop up in a problem, and that's why we find common denominators and multiply these things together, because when I multiply those things, sometimes I get sine squares and cosine squares, and then I can use that property or that Pythagorean identity to simplify further. Right, so my numerator now is going to be sine of theta plus 1. Right, because the sine squared theta plus cosine squared theta, that whole part of my numerator is just going to equal 1. And that's over cosine of theta times 1 plus sine of theta. All right, so I'm getting a little bit better here. I'm making some progress. Right, I started with these two fractions. I combined them together. I simplified my numerator quite a bit. And do you see what can happen here? Right, there's something else we can do here. Right, I have the factor in my denominator of 1 plus sine theta. My numerator is sine theta plus 1. Right, remember, you can switch the order of those. So the numerator is also 1 plus sine of theta, which means my denominator factor cancels out with my entire numerator, and I'm left with 1 over cosine of theta. Right, so since there's nothing else in the denominator, you can think, or nothing else in the numerator, think of that as that factor times 1. Right, so the sine theta plus 1 cancels out with the 1 plus sine theta. Remember, since it's addition, the order doesn't matter. If these were subtraction here, we wouldn't be able to just cancel them out that way. So I'm left with 1 over cosine theta, and just like we saw in the last example, that's one of our reciprocal identities. 1 over cosine theta equals secant of theta, and that's our simplified form of this one up here. Now, a couple things. The answer doesn't always come out to secant theta, right? The two examples that I did on this video, both of the answers came out to just secant. It's not always like that, so don't think that the answer is always going to have to come out that way. It's just a coincidence that the two that we chose came out to the same answer, right? But that's not always going to be the case, I promise. All right, so when you are simplifying trig expressions, you need to know those trig identities. You need to know the reciprocal identities. You need to know the Pythagorean one, the sine squared plus cosine squared equals 1. You need to be able to find those common denominators when you need to, right? All those things are important to know. You need to know that when you have tangent, you change it to sine over cosine. If you have cotangent, it's cosine over sine. Right, so all those identities, and again, I did a video before this where I talked about all the different identities. So if you're not familiar with those, check out that video because you need to use those in order to do these problems. right? And check out the next video that I do where I'm going to talk about proving trig identities.